Okay, when we talk about states of matter, this is the third time I'm shooting this video. It stopped 2 times without me noticing, so now I'm going again. Okay, the thing with states of matter, what I told the kids in class as well, you need to think of it as the 3 little bears, okay? Not in the sense that they look like bears or anything like that. It's just that, when Goldilocks went into the house, she said, this one is too hot, this one is too cold, and this one is just right. That is what I think about the states of matter. So when we talk about states of matter, immediately you need to think of 3, and you need to think of solids, liquids, and gases. These are the 3 forms that anything come in. Okay? A solid is anything that you can touch and not like put your hand through or your finger through. I cannot put my finger through my body or my skin because I am a solid. The liquid coffee in my coffee cup can swirl around. If I poured it over this table, it will take a whole new shape. It will drip off the side. It will kind of just fall apart because it's a liquid. It does not keep its shape. It takes on the shape of whatever you put it into. And then gas is like the air around you, the air that is between the camera and this book. Here is air. All around you is air. You can put your hand through air. We can move through air. We breathe in the air. We use the air because air is a gas, and gases are very easy to manipulate. They are very easy to move. You can literally do whatever you want and the particles will just move out of your way. Okay, so let's take a look at what they look like up close. So everything in this world is made up of tiny microscopic particles is what we call it, okay? That means it's very small pieces of, well, it's not a solid, but very small pieces of matter that are built together to form something. For example, my skin, that's a piece of particle, that's a piece of particle, that's a piece of particle. I can't even move my finger because your entire body, everything is made up of tiny pieces of particles that are holding onto each other. Now, this is where the 3 little bears come in. In solids, you need to think about the particles as being too tight, okay? They are too tight and close together. These little buddies love each other so much that they refuse to let go. If I try to push my finger through this pen, it's not going to work because the particles in the solid are going, girlfriend, nope, you are not coming through here. We are too tight. Now, when it comes to too loose, these particles float away from each other. They don't have a care in the world. They don't care about each other. You do what you want to do. I'll do what I want to do, friend. And these are our gases. Gas particles are not attached to each other at all. For example, if I'm doing this in the air, they are just moving out of the way. They're going, wee, she's pushing me this way, and woo, she's pushing me this way. They have no resistance. They don't stop you from lifting your hand up and putting your hand down. Okay, so they are too loose. And then the one that is just right, if you want to see it that way, are liquids. Liquids, some are close to each other, some take their sweet time and they are distant from each other. So liquids are not as attached, but they might have a best friend or two that they want to cling on to, which is why I can actually see a liquid, because some of its particles are holding on to each other and it gives way in some type of way. They don't entirely move away from us like gases. They still stay where you want them to stay, but they will move out of the way. So that is what a liquid is. All right, now, the next thing you need to know is how these particles work when we change one of these 3 states of matter into another one. Now, here are some new words coming. So, from a solid to a liquid. We will need heat to change a solid to a liquid. If I leave my chocolate in the car on a very hot day, it will melt and become a liquid. Okay? Now I want you to think of it this way, and you will need heat for that. Because these solid particles are all so tight together and they love each other and la-di-da-di-da. But as soon as you put a flame next to them or close to them, think about when you are hot. You don't want anybody touching you. Leave me alone. Go away from me. So they start pushing away their friends. And they go, ew, you're way too close to me. Give me some space, man. I need to breathe. It is way too hot. So they start to push each other away, and the particles drift apart and they become a liquid. Now, if you add even more heat to that, the liquid will become a gas. And that is called evaporation. I know it's a long word, don't worry about it. Evaporation. So now you're adding even more heat to this already liquid, something that's already liquid. For example, think about when mommy boils water on the stove. She puts the heat on very high, the water starts to make little bubbles like that, and then all of a sudden steam comes out of the pot. The steam didn't just come from nowhere. The steam is the water in the pot getting so hot that some of those particles, those two friends that have been holding onto each other, go, listen, I've loved you all my life, but right now I'm so incredibly hot, you will have to leave me alone. They push each other away. They drift even further apart and they become a gas. All right. Now, to get from a gas to a liquid, I told the kids in class, it's not really as if you cool down gas. I mean, that is what would happen if you cool down gas. But I want to think of you as trapped. You trap the gas particles, okay? Think about if, let's say mommy cooked some hot food, she put it into a container and you put the, what is it, Daxel? The lid on the container. Now this hot food is inside of this container. It's getting very hot, okay? The heat, the steam is rising in this container, but it has nowhere to go. The lid is there. They can't get out. They are trapped, these heat particles. So now these gas particles go, oh, we're trapped. And they each grab a buddy because they go, I don't want to go through this alone. I'm scared. We're trapped. We can't get out of this container. And the gas becomes a liquid. Have you ever seen those little droplets that then form on the inside of a container? That's exactly what is happening. So when a gas is trapped and becomes a liquid, we call it condensation. Okay, I'm just going to write it here so that you can see it nicely. It's called condensation. All right, when the gas particles get trapped and they become a liquid. Now, when a liquid becomes a solid, it's because it's very cold, extremely cold. And these friends that have kind of been keeping their distance, some of them decided to keep their best friend by their side. These little particles, they go, oof, it's freezing. I need an entire group around me to heat me up. You know, like when you're cold, you just want to hold something close to you. You just kind of want everything to surround you because you're so cold. So they all group together to form heat and it becomes a solid. And we call that freezing. Think about when you put water into ice trays and you put them in the refrigerator. It's so extremely cold that these particles run together and they go, oh, keep me warm, keep me warm. And then all of a sudden they become solids. Okay, so those are all of the processes. We are still going to go through these things during the week. In class, I'm going to tell you in class we did like a I almost want to say a last man standing type of thing, where I asked questions about it. So we repeated the information the whole time. We talked about solids, liquids, gases, what they looked like, what the particles do as soon as it melts, evaporates, condensates, or freezes. Do you need heat for a solid to go to a liquid? Do you need coal to go from a liquid to a gas? No, you need heat because they move away from each other. Things like that. So I am going to link another video for you that just kind of re-explains it all, or maybe teaches you a little song, because there was this one water cycle song, but I don't want to teach you about the water cycle because I'm afraid you're going to get confused. So I'll go look for a very nice video that's just going to revise what we did here so that you guys can get the same repetition, kind of, almost, that the kids in class got.